Okay, this is a video for the Calc 2 AP exam review project, and it's got two purposes: to be an example of a model for your project and also to be a review of table problems. So the topic I have is table problems. My group is me, and here are the things you have to fill out. The first question about your topic is list the years and numbers where this topic shows up. Table problems is huge. Look, 2016, 15, 14, 13, 12. 2011 from 2000, I think 3 to 11, there was always a Form A and a Form B. In 11, it was on both. In 10, it was on both. In 9, it wasn't on B, but you can tell in the past 7 years, it's been on every possible test that they have asked. So you're going to see a table problem in all likelihood on your exam. The questions they're going to ask on that table problem, there's a little bit of variety, but you are always going to start with this: estimate a slope. And this estimate a slope, it's kind of getting back to the early parts of Calc 1 where a tangent line is the limiting case of a secant line, where you join 2 points and find their slope, and then as those 2 points get closer together, it becomes a tangent line. Use the limit. But for all we need to know is that we need to find the slope between 2 points. Then they are almost every single time going to ask you to do a Riemann sum, and that could be trapezoid, left, right, midpoint. All of those are possibilities. I think probably trapezoid is the most common, but you'll see all of them if you flip through all of these years. And then it's not usually just going to say find this integral. It's going to have some other application of the integral. A lot of times it would be average value. So we'll review what average value means. There's going to be a question likely that involves the intermediate value theorem. Occasionally mean value theorem, but intermediate value theorem is very often. That sets up nicely for a table. A lot of these problems are going to also give you a function that either goes along with the table, it's something else that's happening at the same time as the table, or it's something that happens after the table stops being the values we care about. So it could be the table represents the amount of snow or the amount of fish coming in to a fish market, and the function represents how fast the fish get processed, for example. I don't know why I thought of fish, but it might be some sort of function that's related. It might be during the time of the table or after, and we'll see some examples of those. And then another one, there wasn't really a clear winner for 5th place, but sometimes they'll ask us for an average rate of change, and this is just a good topic to review. An average rate of change is just a slope. It's hard to see the words rate of change and not feel like you have to take a derivative, but question 1 and question 5 are very close to each other, so we'll check that out too in some instances to find an average rate of change. So after you fill out this topic, and really this is an important page, your classmates, your project is centered around these top 5 questions. So some of them will be obvious. You might have to try to narrow it down to get the numbers 4 and 5, but this is what we want to know how to do. If you can do these 5 things for each topic, then you're going to pass your exam. There's really no way around it. So as you're working on your project, focus heavily on these 5 questions so we'll all know what to expect on the day of the exam. And the next thing you're going to do on your project is you're going to have made 4 of these example questions. So this is a table problem, and it has the 5 things that we just went through, A, B, C, D, and E. These are the 5 things that I think are most commonly asked on the table problem on the exam. And so you're going to make 4 pages like this, and the last part of your assignment is to make a video similar to this one right here that talks through working out the first of your 4 problems. So not only will we have material to do, but we'll have one of them fully worked out. So I'm going to solve this one as quickly as possible. The first question, and this question doesn't have any context. I'm not really worried about this problem standing for something meaningful. This function could be measuring anything. I just want to get the skills down. For your 4 questions, you can make the function stand for things. You can be creative. As long as you ask the 4 or the 5 most common parts of your particular topic, that's what matters. And you can have a little variety. Like on this one, I do a trapezoid sum. I might on my next one do a midpoint sum. So you can mix it up a little bit to try to give your classmates some variety. But these 5 topics are the ones that need to show up on all 4 of your pages, like this one. So my first goal is to estimate f prime of 6. So this should work out nicely. It shouldn't be a problem of where they're asking us about. 6 is right here in the middle of 5 and 7. So my best guess estimate for the slope at 6 is the slope from 5 to 7. So slope is y minus y over x minus x. That's going to be f of 7 minus f of 5 over 7 minus 5. So f of 7 is 3. F of 5 is negative 2. 7 minus 5 is 2. And on top we get 5. Bottom we get 2. So there's no context, so there are no units, but the slope between these 2 points is 5/2, and that's the best case scenario estimate I have for f prime of 6. All right, so moving on. Question B, explain the meaning of 1/12 times the integral from 2 to 14. So this is something you should recognize. When you see this integration with the fraction out front, this means average value. 1/12 the integral from 2 to 14 of f of x is the average value of f of x on the interval 2 to 14. All right, when you see that fraction out front, when you're dividing the value of the integral would be the area under the graph. 1/12 of the integral is the average value of that function. And we're asked to estimate this value with trapezoid sum for trapezoids. Okay, so I forgot my 2 on my 1/12. 1/12. All right, so my estimation of this value is going to be 1/12 times these 4 trapezoids. And if you recall a trapezoid, it is width divided by 2 times the left plus the right. So this first trapezoid stretches from 2 to 5. Okay, so my width is 3 divided by 2 times -7 plus -2. That's my first trapezoid. And it's going to have a negative value because the graph's under the axis at these 2 locations. My next trapezoid stretches from 5 to 7, so that's a width of 2. We always divide by 2. The 2 y values are -2 plus 3. All right, my next one goes from 7 to 10, so that's a width of 3. My y values are 3 and 1. And my last one has a width of 4, and my y values are 1 and -2. So for the sake of time, I'm going to pause for a moment and get this number and resume. I encourage you to work it out also. All right, so I got -0.708, 3 repeating in my calculator, which is -17/24. And assuming I didn't make a arithmetic error, that kind of makes sense. This function seems to spend most of its time in the negatives, but kind of close to 0, and then it gets up to 3 and 1 for a little bit, but it doesn't get really high. It should be something relatively close to 0, but I think that it's definitely in the negatives overall. All right, so there's my part B. Main focus is the Riemann sum, the trapezoids, but it usually asks you to apply that. In this case, we apply that to the average value. All right, the minimum number of zeros that f of x has on the interval 2 to 14. So the intermediate value theorem is what this is asking us about. Since, and there's a, we want to model our answers after the AP question. So you want to look at these in the numbers and years that were listed on the previous slide, but you don't have to have exactly word for word what they wrote, but you need to explain how you know these answers with good mathematical vocabulary and symbols. You don't want to say things like, since it changes from negative to positive and positive to negative, there have to be 2. We want to be a little more specific. So I'm going to say since f of 5 is less than 0 and f of 7 is greater than 0, there must be a 0 on the interval 5 to 7. And what I haven't addressed in the question, that's because I'm an amateur question writer, is that the function needs to be continuous and differentiable. But I guess just, in this case, just continuous. But there's my first one, and since f of 10 is greater than 0, and f of 14 is less than 0, there must be a 0 on the interval 10 to 14, both of these by the intermediate value theorem. Okay, so make sure you get the words intermediate value theorem in there, because that's the theorem we're using, and that's the kind of vocabulary that you need to include in your answer. Okay, f of 20. So what usually happens is there's some sort of function that's either going on after the table stops or during the table. In this case, for 14 and above, the derivative of f is given by e to the sine 2x. So f of 20, this is testing us on, basically it's an application of integration. If you want to know how much something has changed, you integrate its derivative. You integrate the rate. So f of 20, and I always say it's where you end up is where you were plus how much you changed. So where I end up, f of 20, is where I started, and in this case I'm starting when the table stops. So that's at a value of -2, plus the integral from 14 to 20 of e to the sine 2x dx. And this would be more meaningful if it stood for something, but f of 20 could be anything, the amount of water in a bucket or the amount of whatever. I just want to know f of 20. And when the table stops, the function takes over. And if you want to know how much a function changes, you integrate its rate, integrate its derivative over the time period. So I'm going to pause again and put this in my calculator and come back with the answer. All right, and as I type that in, I'm thinking about how part of this question would work for a non-calculator part, and part of it you would need a calculator. You can mix that up on your question, because most of these could happen on either section of the exam. We just want to get the most common questions they ask. So in this one, when I type it in, -2 plus this integral, I get 5.473. which brings up another point. We want to use 3 decimal points on the AP exam. So the function, the table stops counting at 14. So from 14 to 20, the change in f is the integral of f prime from 14 to 20. And finally, this one's going to be similar to question A, average rate of change. All right, rate of change says to me derivative. But average rate of change is just slope, okay? It doesn't matter how far this function goes up and goes down and moves all around. The only thing that matters for an average rate of change is where we started, where we ended up, and how long it took us to get there. Okay, if it takes me 10 hours to drive 500 miles, my average speed was 50 miles an hour. I might have driven really fast, then slowed down, then stopped for lunch. But I went 50 miles per hour on average, and that's what this is asking us to do. So the average rate of change from 5 to 10 is just the slope between 5 and 10. So from 5 to 10, I go from 2 down, or from -2 up to 1, so that's an increase of 3 over an x span of 5. So that is 1 minus -2 over 10 minus 5, which is 3/5. That's it for average rate of change. Okay, so like we do a lot of times in class, don't feel like something needs to be difficult. The difficulty is just knowing what they're asking. The execution, the finding of the number, is usually the easiest part. So this is table problem number 1. You should see some similar questions on your exam, and this serves as a model of what your video should look like for your project.